Hello students, welcome to the Sarat Chandra Academy, and today we will discuss 2026 January attempt 21st Jan evening shift paper. So let's start. And paper came very easy. There were few questions which were from notes directly and most of them are formula based. Maybe one or two confusing also. Let's see. So here we have first question, refractive index of prism is √2. What should be the angle of incidence for a light ray such that the emerging ray grazes out the surface? So you have to do a little bit of reverse calculation. See how. Here he is saying incidence angle given √2, 45, 45, 90. Okay, fine. Like here he is saying grazing. So here it is going and then grazing out like this. Okay. If not visible, I will use another color. Red will be fine. So here if I give a normal, this eye we don't know, here grazing this is 90 degree. So I can calculate this critical angle, right? So how you will calculate? You will say √2 into sine C is equal to 1 into sine 90, that is 1. So here C will come what? 45 degree. Now we know that R1 plus R2 is equals to A, right? So by this, that I can say this is also 45 degree. So now you can say 1 into sine I is equal to √2 into sine 45. Here I am applying Snell's law, right? So sine I came how much? This came √2 into 1 by √2, 1, right? So this is I equals to 90 degree. Okay, third option. Got the point? I hope so. This is clear. Next question. For YDSC experiment, and this is memory based question, so maybe there will be some of the mistake, so we can clear it. Okay, we will discuss what can be the possible question there. So in the YDSC experiment, angular fringe width is talking about. So angular fringe width, both the statements are, if distance between the slits and screen increases, then width. So here it will come angular fringe width. Okay, so first of all, what is the angular fringe width? So if you remember, we had beta, that is fringe width, right? Lambda d by d, right? And then we define angular fringe width. Okay, that will be what? Lambda by d. Okay, so this way, if you talk about if distance between the slits and screen means capital D, right, increases, then fringe width, angular fringe width will increase. No, because it is not dependent upon capital D, right? Slits and screen distance is what? Capital D. It is not dependent upon capital D. Then after, so this statement is false. Okay, so this is false. Then after statement 2, angular fringe width depends on frequency of source. So it depends upon the lambda. So it depends upon the frequency, right? So statement 2 is true. So I can say second option. Okay, next. If we go for next, so here he is saying two capillaries are dipped in two different liquids having meniscus radius R1 and R2. So first, little bit of maybe you can get confused, but not big problem. R1 and R2, R1 is bigger. See here, this is small R1, okay, not the capital R1. So these are the small R1 and small R2, maybe the radius of the tube, doesn't matter. So hold this question. And surface tension T1 and T2, if density of the liquid are same. So density of the liquid is same, okay. Meniscus radius R1 and R2 given. So first of all, you understand H is equals to what? H is equals to 2t cos theta by rho g r, right? Small r, right? And he gave capital R. So we know, if I can draw the figure also here, if you remember in this liquid, how we say the capital R and small r relation, that also I can tell. If sometimes students sometimes forget, so that's why theta this one, so this is also theta, so we say this is capital R, this liquid's radius, and this is small r, which you put here, and you put cos theta here, right? So here we can say cos theta is how much? Cos theta is what? Small r by capital R, right? So small r is cos theta into capital R. So if you put here, cos theta cancel out, so H equals to 2t by rho g capital R. That capital R which he is discussing here. Okay, so this is the main thing. Now if you see, he said density is same, G obviously same, 2 factor is same. So here you can say surface tension is proportional to H into R. Okay, here the discussion is between the surface tension, height, and your liquid raised and radius of meniscus. So now here if you discuss that T1 into equal to T2, if surface tension is equal, right, then who will have more radius will have the less height. So by that I can say if T1 equal to T2, then if R1 is bigger, then H1 should be smaller than H2, because if radius is bigger, then H will be smaller, then only T1 equal to T2, inversely proportional, so H1 less than, so fourth option. Okay, so we have to go with this formula, but sometimes students get confused that here cos theta is also there, how we will deal with it, because he is not talking about the radius of the tube. Okay, he is talking about this liquid, right? So this is the radius he is talking about. Okay, and if you don't remember this thing, you can say directly rho gh equals to 2t by capital R. This was the thing we do, right? Here pressure decrement will be equal to the height. I hope you remember. Okay, next. A particle is performing SHM with frequency f0. Okay, if frequency of oscillation of its kinetic energy is 176, then find f0. So if you understand this thing, there are multiple ways. We have shown this with the graph also, you can see. Okay, if you check the kinetic energy, right? So kinetic energy, what you write down, half mv square. Okay, or you can say kinetic energy is half k, okay, a square into, if you take x equals to a sine omega t plus phi, right? Then you can say v is equals to what? Cos will come a omega cos omega t plus phi. Okay, so your kinetic energy will be how much? Half mv square. Directly also you can write down, but just wait. So here what you will say, half m omega square is k, and then after you have a square cos square omega t plus phi. Now remember, when you are comparing the phase, you have to convert this into linear, so you will use the cos 2 theta formula. So there, if you understand, here his omega is what? 2 omega, and here his omega is omega, right? So from omega you can, frequency is directly proportional. So if he is saying for the kinetic energy is 176, then f0 will be half of that, 176 by 2. Okay, because here it is getting double, so he is discussing this. Okay, so this one will be half of that frequency, not angular frequency. Okay, so that is directly proportional. Got the point? So 176 by 2, I think 160, so 88. Okay, that's it. This was easy question. Next, this one looks hard but not. See, in steady state, assume diodes are ideal. So find charge on capacitor. So how we will find out charge on capacitor? This is one capacitor, one battery, resistance, diode, resistance. Okay. So if you see here, current will come. This is higher potential, this is lower potential. If this is higher potential, then I can say this is in reverse bias, right? This is in reverse bias. So this gone, this is out of circuit, right? And the current will flow through this one only, right? Through this one. Getting my point? Because this will be in the forward bias. Now forward bias, no resistance because ideal is there. Now 4, and then current will, how current will flow? So if we talk about the circuit which we have to discuss is what? Here 2.5 volt battery, 1 ohm resistance, and then here 2 ohm resistance, and then capacitor, and then here diode will not do anything, and here 4 ohm resistance. Okay, so if we talk about this, then if steady state is achieved, then what will happen? Capacitor is fully charged, so here current will not flow, so current will flow only through this only. So you can discuss just this thing, that's it. Okay, so now what will happen? If current is flowing, then we can say how much? V equals to IR. So R is how much? 4 plus 1, these are in series now. So 4 plus 1, 5. So we can say 2.5 is equals to I into 5. So I will be 5 by 2, 1 by 2, 0.5. Okay, correct? 2.5, 5 by 2, 5 cancel out, 1 by 2. Okay, 0.5 came. That means now you have to go for the charge on the capacitor. Okay, think in these terms. This resistance, how much potential, like I can say 4 ohm resistor, how much potential difference is there? That much potential difference will be across the capacitor. Okay, that kind of question already in the notes. Okay, way harder than this we have done in the notes. So this resistance is not having any potential difference. Why? Because current is not flowing. If current is not flowing, then I can say V equals to IR. V is what? Potential difference across this resistance. So if I is not there, that means V is 0. Means potential difference across this resistor 0. So whole this complete potential difference 4 ohm is going across this capacitor. Okay. So here how much is the potential difference across this 4 ohm resistor? So I can say V of 4 ohm resistor will be how much? IR. So I is 0.5 into 4. So that will be 2 volt out. Correct. Now 5 microfarad. So you can say Q is equals to CV. So charge will be how much? C. 5 microfarad, that means 5 into 10 is to power minus 6. Okay, in micro only is dealing, no problem. 5 microfarad into V, 2. That is 10 microcoulomb. Okay, your answer is second option. Got the point? Okay, easy only. Just you have to identify which one is forward bias, which one is reverse bias. Fine. Then next. A boat can row at a speed of 36 km per hour in still water. The river is flowing at 18 km per hour speed. If boat crosses the river in minimum time, then find drift of boat. Okay. So this question is also easy only. If you see 36 km per hour, then how much in meter per second? 5 by 18, right? So 5 by 18, if you will multiply, you can say 1000 by, if someone don't know, I hope so you know this thing, 0.05 by 18 comes, okay, conversion factor. So for meter per second, okay, because he is asking then find drift of the boat, maybe in meter only answer if this is single, correct, like you can say integer type. So 36 km per hour will be 36 into 5 by 18, so this will be 10 meter per second, okay, and here if you say the river is flowing at half, so that will be 5 meter per second. Okay. Now if boat crosses the river in minimum time, then find the drift of boat. So understand here, if this is the river, if you have to cross in minimum time, river is flowing this side with a speed of 5 meter per second. Correct. So you have to go straight by 10 meter per second to cross it in minimum time. Okay. Got it. And if you want time also, which he is not asking, so for that he should give some information which he didn't give. Okay, fine. So 10 meter per second, the boat row at a 36 km, the river is flowing this. If boat crosses the river in minimum time, then find the drift of the boat. So here he have to cross 10 meter per second going some d distance, right? So 5 meter per second this side, 10 meter per second this side. So here overall motion will be this way, right? So this will be his drift. Okay. Now if you want time, then time you will solve. If we say this distance is d, then d will, the time taken will be what? This is 10 meter per second in this direction, which is responsible for time. If you are like, think in the basic, okay, if particle is moving this side with any, he have two component of velocity, horizontal and this way. So if he is moving this way, this way, this way only, then he will never able to cross the river. So for the time calculation, we have this way, perpendicular to the river, right? So which have a 10 meter per second. So you will have how much? D by 10 meter per second. Okay, this is the amount of time needed. Now drift, horizontal displacement, right? Drift will be what? Velocity into time taken. So velocity is how much? 5, and time how much? D by 10. So if he have to go give the distance between these banks of the river, then only we will able to solve. That is not given here. It's okay. So if this question completes, then we can solve. So this is the way, basic thing. Okay. Next. So here if we see in this question, then we have what? A charged particle mass m charge q is accelerated through a potential difference of 1.21 volt if de Broglie wavelength of this particle is found to be alpha into 10 to the power minus 12. Okay. So see here. So we can say directly de Broglie wavelength, first formula is that only h upon under root of 2mq into v. So 2m in kinetic energy you say, so q into v, that we can write down. But remember it is memory based. He should give here charge started from rest and those all things. Maybe in the JEE main he will not give it. Okay. So you can consider this formula. Okay. Now h value, here h value is wrong. Okay, 6.6 into 10 to the power minus 34, right? divided by under root of 2 m into q is what? 18 into 10 is to power minus 46 into v, 1.21. So if you solve this, what will come? 6.6 as it is, okay, into 10 is to power minus 34, and here what will come? 8 to the 18 into 2, 36, 6 into, this is 1.1 into 10 is to power minus 23, right? So by this you can say 23, 10 is to power minus 11. This will come, okay? So he's 10 is to power minus 12, he is saying. So compare with alpha into 10 is to power minus 12. So alpha will be what? 10. Okay? So answer will be 10. Next. Next question. Two persons are traveling in same direction in car along two parallel tracks separated by 10 meter with speed 36 km per hour, 72 km per hour. If mass of man and car is 1000 kg each, find angular momentum of one car with respect to another. See here. Then if you remember, we have discussed momentum. Okay, so how we see the angular momentum? Like with respect to one person, with what velocity you will see this person and in which direction you will see him going. According to that you will write down. So according to him, he is having a mass of 1000 kg going with, I can say, relative speed. You can find out relative velocity 72 km per hour, 36 km per hour, 36 into 5 by 18, how much? 10, right? And this will be what? 72 into 5 by 18, correct? So this will be how much? Double of that, 20 meter per second, right? If both are going same direction means relative speed subtract, so 10 meter per second. So he's going with 10 meter per second relative speed, and the distance will be the perpendicular distance only, so that is given because going parallel, right? So 10 meter. So here MVR, this is R perpendicular only. With respect to this particle, he is going along this line with a 10 meter per second speed. So I can say MV R perpendicular. So M is 1000 into V is 10 into R is also 10. Okay, so 10 is to power 5. I think fourth option. If you convert in, because this is given kilometer per hour, so kg meter per second calculate. Okay, so fourth option. Next. Fast I am doing because there is no point of getting slow in this. Keeping the significant figures in view, the sum of the 5.01, 153.2, 0.123. So if you remember, there are different rules for subtraction addition and your multiplication division, right? So in subtraction addition, we just say that after decimal, the digits are there. In that minimum, you will count. So how? I am saying like this, 5.01, 153.2, and you have 0.123. Okay, we also understand that how this particular thing came, that why we are doing so, why we are considering minimum number of digits after decimal, right? So here you don't know what is this here, what is this here, what is this here, you don't know. That's why you do like that. Okay, so if we now solve for this, what will come? 3, 2 plus 1 3, 2 plus 1 3.538, 158.333. But that's not the answer. You have to consider minimum number of digits. So here after decimal, this has the minimum number, so that is 1. So round off, if you do 3, 158.3, that means second option. Okay, according to significant figures you have to answer. So 158.3, second option is your answer. Let's do next. See, figure shows a ball falling in a viscous medium with a coefficient of viscosity eta if error in the measurement of radius is delta r, and that is measurement of terminal velocity delta v naught. Density of the ball in liquid is exactly known, then the fractional error in the measurement of eta. Okay. If terminal velocity formula you remember, that's very good. Otherwise you can solve also that downward mg is acting, upward buoyancy and viscous force will act. So you can say mg is balancing the your buoyancy plus F viscous. By this we solve, which is given in the notes. You can write down this in density of the fluid terms, and this you can write down density of the body terms, means sigma, right? So your formula of in here 6 pi eta RV. By that you get the velocity, terminal velocity formula if you remember. Okay, V naught he is saying here. That will be what? 2 by 9. Here it will be sigma minus rho. Okay. and here r square g by eta. Okay, this was the formula. So here if he is talking about eta, so eta you bring this side and v naught that side. Okay, and r and your v naught is only dealing, g is constant, this is only also exactly measured, right? 2 by 9 is a multiplication factor. So eta you can say some constant into r square by v naught, right? Then how we solve? What do you understand by this, seeing this thing? You remember we do this thing by taking ln and differentiate. So if you take ln and differentiate, what will come here? Delta eta by eta equal to 2 times of delta r by r minus delta v naught by v naught. But the thing is, he is talking about the error, fractional error. So in error we always add, right? So plus will come. So by that I can say first option. Okay, error is always added, right? That's it. To find out the maximum variation, that's it. I hope it is clear. First option answer. A ring and 2 rods, each of mass capital M, are able to rotate freely about its center as shown. Find acceleration of each block. There is no slipping between string and pulley. So if you see this question is doable, okay, easily doable, but little bit lengthy, not much, little bit lengthy. So if you feel like I should leave it, hold this question, okay, for time being, and then go for the next question, which is easily doable. That only you do first. Okay, that should be the priority, so that you can score the maximize, and then after come back from the starting, and then you will understand. So here first, let's mark all the things. So how this, generally what we do is, in this question is exactly in the notes, but generally what we do is we give here moment of inertia of the pulley, but he made the pulley with the help of 2 rods and one this ring. Okay, I think ring only, ring and 2 rods. So let's discuss this. Moment of inertia, how much will come? If you consider radius r, right? So I can say for the ring, it is mr square by 2. Sorry, mr square, ring it is, right? Mr square plus for the rod. If you see this rod, this is hinge point is in the middle, this rod will rotate like this. Correct? So this is what? ml square by 12. So ml is what? 2r 12 into 2, because 2 rods are there. Okay? Both are having same mass, mm. Right? Each of mass capital M. So this is moment of inertia. So what you see here is 4, 3, 2 by 3, so 5 by 3, right? 1 here, and this is 4, 4, 3, 2 by 3, 5, 5 by 3, mr square. Okay, I think this only. Next, here I will write down the equation only. Okay, I will not solve this thing. Let's say capital M is bigger. Okay, as per the options also you can see capital M he considered bigger, means this direction you can assume alpha, right? Here let's say tension T1, so here T1, here tension T2, here T2. Okay, downward is small mg, downward here capital Mg. Okay, now I can say what this block will go with an A acceleration, this will come down with A acceleration only. So this is A, so this is also going down with A only. Correct? Now what we can do? So now we have to write down the equation. So first we have said in this, first you will write down all the translational. So translation, what bodies are doing translational motion? This body. So here we can say T2 minus small mg is equals to small m into A. Okay, and here what you can write down? Downward acceleration you assume na? So capital Mg minus T1 is equals to capital M into A. Okay, these are the two translational. Then rotational. Rotational what? This body is rotating, right? So I can say here net torque equals to I alpha. So net torque is what? T1 torque this sense and T2 torque opposite, right? So alpha, if you see what we assume, alpha this sense, then only this block will go down, up, and this block down. So alpha this sense. So if alpha this sense, then T1 torque will come positive and T2 torque negative. So you can say T1 into R, okay, minus T2 into R. This is the net torque on the pulley is equals to I alpha, right? So moment of inertia you can put into alpha, right? This is translational. This is all bodies which are doing rotational motion. So we have one only. And then after, no slipping condition. So no slipping, if you see, I'm properly explaining. Here at this point, if you see the pulley, if you see this is the pulley and this is the string, right? So I can say that the pulley is rotating with alpha. So this point is going above with r alpha acceleration and string is going above with a, right? So we can say a equal to r alpha. This is the equation. So if you count number of variables, he is asking the acceleration, okay? So if you count number of variables, t1, t2, alpha and a, 4 variable, 4 equation, okay? So a you want, so eliminate the variables. How you will eliminate? Let me do that also. One equation you can bring it. T1, T2 value here put, okay? And then alpha value here put. Whole equation will come. This equation will come in A. Getting my point? T1. So T1 value how much here? T1 value how much? Mg minus Ma. So capital Mg minus capital Ma, right? Into R minus T2. T2 is how much? T2 is how much? Mg plus Ma. So small mg plus small ma, right, into R is equal to I into alpha is how much? A by R. Okay, that's it. So this whole equation will come in A that you can solve easily, and that's your answer key. Got it? I hope so you will be able to do this. Next. Current I is flowing in the long wire as shown in the figure. Find magnetic field at the center of circle. So if you see here, magnetic field at the center of circle. So if you see, this question is in the notes. Okay, exactly this question. So here if you see, you can say this is like semi-infinite wire, then semi-infinite, directly you say this is an infinite wire. Okay, and there is a circular loop. Here actually we say in the notes that this gap is very small. Okay, in the notes we say like this. Okay, so here also we have to consider. Now if you see here, by this infinite wire, magnetic field how much by infinite wire at a distance r? How much will be the magnetic field? I can say B will be how much? Mu naught I by 2 pi r, right? 4 pi r comes sin theta 1 plus sin theta 2, that is 1. 1, 1, 2. So 2 cancel out. This is the value, right? By the infinite wire. And by this circular loop, how much will be? So this one circular loop how much? Mu naught I by 2r, correct? Okay, theta by 2 pi you say, that got 1. Mu naught I by 2r. But the thing here is that by the infinite wire, how you find out by magnetic field by infinite wire? You take your thumb in the direction of magnetic field, and then your fingers you will turn with 90 degree, then it will tell the magnetic field direction. So here, due to infinite wire, on the center magnetic field will be out of the plane, correct? Okay, and by this circular loop, magnetic field is inside the loop, inside. Okay, so both will be subtracted. So by that you can understand that this is less, this is more. So you can say net will be how much? Mu naught I by 2r minus mu naught I by 2 pi r. Okay, so this is memory based only, so maybe options they gave wrong. Okay, one of the option is correct. You can say if you consider here minus, right, then this is okay, right? Okay, next. Memory based, that's why. Okay, next. If position of the particle is given by x equals to t square plus t plus 1, okay, so this particle is moving ahead like that. Mass of particle is 2 kg. Find work done by the force from t equal to 2 to t equal to 3. Okay, easy only. X is given, v you calculate, v will come how much? 2t plus 1. And if you go for acceleration, how much acceleration is? You can say 2, differentiation. Agree? That's it. So force came how much? Net force on the body is equals to mass into acceleration. So mass into acceleration, acceleration 2, this is also 2, so 4. So 4 Newton is the force, right? Now, 2 ways I am telling. Okay, here if at t equal to 2 seconds, where is the x initial? At t equal to 2, where he is? If you see here, 4 plus 2 plus 1. So 4 plus 2, 6, 7. Okay, and x final where? T equal to 3. So 3, 9, 9 plus 3, 12, 13, right? So this is 6, so delta x. So you can say work done is equals to F into delta x, because he is moving forward and force is also positive only, no problem. So you can say this is 4 into 13 minus 7, everything in SI unit. So how much came this? 6. 6 for the 24. Okay. Other way, you can go for velocity. At t equal to 2, you can find out velocity. And t equal to 3, you can find out velocity. And k final minus k initial is the work done. Okay. That is also one way. Next. Terminal velocity of a spherical ball of radius 6 mm in a liquid is given by 20 centimeter per second. Okay, find terminal velocity in centimeter per second for a ball of 3 mm radius. So this is very easy. Just now we discussed the terminal velocity formula. What was that? 2 by 9. Okay, sigma minus rho, whatever you write down, density of the body minus density of the liquid. Okay, into r square g by eta. So if I see here, okay, that directly you can say 6 to 3, right? Ball radius is becoming half, right? If radius became half, then terminal velocity will be 1/4, correct? So 1/4 means 20 by 4. So 20 by 4 means what? 5. And everything is in same centimeter per second only, okay? Or you can put the values, same unit put and then divide, okay? Answer will come. So 5 centimeter per second means first option, answer, directly. Got the point? That's it. Fluid mechanics 2-3 questions came, okay. Total length, so this is your meter bridge. Total length of potential wire PQ is 50 centimeter, okay. Instead of 1 meter he gave 50 centimeter. In the arrangement shown in the figure, find out balance length PU, okay. See here, easy only. Assume this is X, right? So this is what? 50 minus X. Okay. So now if this is showing 0, okay, balanced, that means here resistance, like you can say lambda something you have to assume, which we already defined. But those who have not studied, lambda is what? Resistance per unit length. Okay. Like resistance you say rho L by A, right? So here resistance per unit length you define, okay, rho by A, okay. So resistance per unit length you define, so then here resistance how much? In this you can say resistance will be lambda into X, right, and here how much? Lambda into 50 minus X. Now if this is a balanced Wheatstone bridge, then we can say that 6 by lambda X is equals to 4 by lambda into 50 minus X. Some people solve directly without lambda, but I am trying to explain why we do that like that. Okay. So galvanometer will show 0 reading at that point. Okay. So now cancel out 2, 3. Multiply this side. 3 150 minus 3x is equals to 2x. 5x, x is 150 by 5. So that is 30. Okay. So PO only 30. So for third option. Okay. I hope so this is also clear. Next. In YDSC experiment, central maxima shift by 20 mm. If a slab of thickness 20 micrometer and refractive index mu is placed in front of one of the slit, if distance between the slits is 4 into 10 to the power. So this is small d given. Small d given. Okay, screen is placed 1 meter, this is capital D given, okay, and the refractive index is, okay, so central maxima shifts slab of thickness, so this is T given here, okay, and this is the Y which is given. Now I will not use formula, okay, try to understand, because wave optics many people have problems like what they should do. So for any point we can say x2 minus x1, okay, but x1 instead of x1 we have to write down that x1, this is the distance, but here what will be there? Minus t plus mu t, okay, this is the path difference. Got it? x2 minus x1 minus t plus mu t, so this is equals to n lambda, okay, path difference. Now by the physical calculation we can say x2 minus x1, which is just a mathematical calculation. Here if you take t common, then what will come? Plus, let's say. So if you take t common, this is minus minus plus and this is minus, so 1 minus mu, okay, actually here minus comes, wait for it, n lambda. Now x2 minus x1 is d sine theta, and sin theta is tan theta is y by capital D. Okay, so by that you can say this is what? Y x to d sin theta. So d sin theta is tan theta is y by d, so this is y by capital D. Plus here you take minus t mu minus 1, and for central maxima n equal to 0, right? So this is 0. So by this, sometime people directly say, sir, dy by capital D is equals to t into mu minus 1. But how this came, you should know that also. Okay. Now he gave y, he gave, right? Thickness t he gave. Okay. Small d he gave, capital D he gave. He has a mu, right? So let's calculate the mu. T divide and then one side this side. Okay. So mu will be what? Dy by capital D into t plus 1. So if we solve this, small d, 4 into 10 to the power minus 4 into y how much? 20 mm. So this you can put 20 into 10 to the power minus 3 divided by capital D 1 meter. Okay, 1 into multiply, and then small t 20 micrometer. So 20 into 10 to the power minus 6. So if you cancel out, you can say 20 directly gone. 10 to the power minus 6, 4 minus 2 minus 1, 0.4, right? And 1 was already there, so plus 1. This is 1.4. What is asking? Alpha by 10. So 1.4 is equals to alpha by 10. So I can say alpha is equals to 14. So answer is what? 14. Okay. So this you should understand. Okay, because JEE main may be possible, not asked, but if you understand, then you will be able to answer something which you have studied very long ago. Okay. Otherwise, formula based, how many formulas you will remember? That's only the problem. By the way, many difficult more questions have already done in the notes if you study properly. A medium having conductivity 10, electromagnetic wave of frequency 100 megahertz are passed through this medium. Find ratio of maximum displacement current and conduction current. Okay. Now try to understand. Little bit difficult, you can say this thing. Okay. Sometimes they don't click what he is asking. Okay. If you remember properly, then there was one formula. Electric field is equals to, you had conductivity into J. Sorry, resistivity into J. J is what? Current per unit area. Okay. So resistivity is 1 upon conductivity. Okay, 1 by sigma. So here you can say I is how much? E sigma A. Right. So now he is saying electromagnetic wave. Okay. So here you have this current is not, electric field is not like this. Sigma A as it is, but electric field will be E naught into sine omega t minus kx. Okay, this will be the thing. So this is your conduction current. Okay, this is your conduction current. Getting my point? Now we come to displacement current. So displacement current, if you remember displacement current, ID, then what you write down? Epsilon naught. Okay, here medium is different. So epsilon naught, epsilon r will come. Agree? And then after what will come? Here you can say d phi E by dt, if you remember. Okay. So phi E, flux, how you write down? Electric field E naught sine omega t minus ks, and for the flux area multiply, right? So A multiply by area. So A will come outside without differentiation, E naught will come, sine omega t minus kx differentiation, cos, and omega will also come out. So ID, if you see, then what will come? Epsilon naught, epsilon r, area out, E naught out, and then you have in multiply, omega will also come, right? And then cos omega t minus kx. Okay, this is in multiply. I will write down it again. Here, ID will come how much? Epsilon naught, epsilon r, and for him A into E naught, and then differentiation of sine omega t minus kx, that will be omega out, cos of omega t minus kx. Got the point? Till here clear? Next what he is saying, find ratio of maximum displacement current and conduction current. So if you want to maximize your displacement current, then you will say cos is, this particular thing is 1, okay, and this sine also 1, right? If you divide ID by IC, as per the given information. Okay, ID by IC, if you will do, what you will have? ID epsilon naught epsilon r, maximum displacement current. Okay, first displacement only, then okay, A E naught omega divided by, here you have sigma A E naught. Okay, so A E naught cancel out, epsilon naught epsilon r omega by sigma. Got it? So here these all values are given to you. Okay, this conductivity given, epsilon naught epsilon r you know, and omega you know, 100 megahertz given frequency. Okay, so by that you can solve, okay, and you can get the answer. I hope this is clear. Okay, this may be little bit you don't remember this thing. Actually I used the formula here, that exactly what I wrote in the notes. If I want to tell, E is equals to how much? Rho into J. Okay, this is the thing we mark important in the notes. Okay, I hope so this is clear. Next, in a circuit there is a battery with internal resistance small r and EMF capital E, which is connected to an external load resistance capital R as shown. Find value of capital R so that maximum power dissipates across capital R. Okay, so either if you remember that condition, okay, then you can directly say small r equal to capital R. But how it comes, if you want to understand, power dissipated across this capital R resistance will be what? I square R, and I is what? V by R plus small r whole square into capital R. So if you see here, V square is constant, R by R plus R ka whole square. Okay, if you differentiate this, okay, for the maxima, then you will have the condition capital R equal to small r. Okay, that's it. So first option answer. Next, two spheres of same mass m and radius r and charge at separation 4r. Okay, so initially separation 4r, okay, are moving with a speed u towards each other as shown in the figure. Okay, so mass m charge q, identical everything. Find the u minimum so that they collide. Okay, we have to find out minimum velocity for which they collide. Now what is happening here? Charge, because of charge repulsion is there, and because of masses attraction is there. Okay, but how much minimum velocity both we have to give so that at least they can collide. Okay, means just touch also, that is also enough. So you can say the final condition we want is what? That they are just here with the u equal to 0. Speed how much got? 0. We just touch each other. That we can consider collision. Now how you will solve this? See, for that, initial condition energy conservation, okay, potential plus kinetic, and final potential plus kinetic. Okay, now here electrostatics and your gravitation both together came. Here if we say initial, right, so kinetic energy how much you say? 2 into half mu square, correct? This is the kinetic energy. Okay, plus potential energy by the charges you can say k q square by 4r. Okay, and the masses are there m, so by that you can say minus g m square by 4r. Okay, this is potential, is equals to final kinetic energy 0 plus potential. If you talk about, then the gap will be how much from center to center? 2r, right? R radius, right? So here 2r. So what you will have? Potential kq square by 2r minus g m square by 2r. Okay, so here 2 to cancel out, mu square remaining. So u square, if you talk about mu square, let's say mu square, here you have plus 1 by 2, here plus 1 by 4, that side 1 by 2 minus 1 by 4, 1 by 4. So positive 1 by 4 is there. So you can say kq square by 4r, and here this is minus 1 by 2, here minus 1 by 4, that is plus 1 by 4. So minus 1 by 4 remaining. So minus g m square by 4r. Okay, so here if you divide m, I think option should match. 4 mr, we are saying 4 mr kq square minus gm square, first option. Okay, that is your answer. I hope so this is clear. Just the energy conservation, kinetic plus potential, kinetic plus potential. Next, in an LC circuit at t equal to 0, capacitor is fully charged and zero current in circuit. At t equal to t naught, 25% of the energy of the capacitor goes into inductor, then the value of t naught is. Okay. At t equal to 0, what is the condition given? That capacitor is fully charged. Okay. And at t equal to t naught, 25% of the energy of capacitor is went into the inductor. So how much remaining? 75%. Okay, you can deal with both way. I will go with the capacitor only. So if you remember, if not remember, that's your headache. Okay. How we did that? If you apply in this at any point of time, if you will apply the KVL, right, you will get that L di by dt. So I, you can say dq by dt, right, is equals to minus V. V is what? Q by C, right? So from here you understand that this is d square q by dt square is equals to minus 1 by LC into Q. Okay, so this is something like SHM. Okay, so by that I should understand that here charge will come. Q is equals to Q naught, capital Q, let's say. Okay, that he is using capital Q only. Then after t equal to 0, you want what? Fully charged, right? We use cos omega t. You can say sin omega t plus pi by 2. Okay, because he gave the t equal to 0 condition. So according to that, you have to understand. Okay, and if you differentiate here, you can say current also 0 at t equal to 0. So this is satisfying the condition. This will come. Okay, means current is, the charge is oscillating. This is the thing. Now he is saying energy, right? So at t equal to t naught, 25% energy of the capacitor goes into inductor. Means how much remaining in the capacitor? 75%. So if we talk about energy, then E is equals to what? Q square by 2C. At any point of time when charge is Q, what is the energy in the capacitor? Q square by 2C. So what we can say energy? Let's denote it with U. Q is what? Q square by 2C cos square omega t. Agree? Right? Now this is any point of time. If you talk about t equal to 0, right? U naught, let's call it, or U t equal to 0. That you see, then t equal to 0, you can put Q square by 2C. That's the energy, obviously. Now he is saying 25% energy went. So how much remaining? 75%. Means when you will put t equal to t naught, right, then this is 75%. So the way of saying is this thing, that 75% of Q square by 2C is equivalent to Q square by 2C into cos square omega t naught. And time is t naught. Okay, that time only 75% is remaining of total. Okay, so this is the thing. 75% of the total, the initial energy, is remaining when time is t naught. So this is the any point of time, which is at this time, 75%, because 25% went, okay, in the inductor. If you read, 25% energy of capacitor goes into inductor, right? So by this I can say Q square by 2C cancel out. Under root when you will take, this is 3 by 4, so root 3 by 2 cos omega equal to cos omega t naught, right? If you understand here, okay, omega is what? 1 upon under root LC, right? So here cos root 3 by 2 means 30 degree, okay, pi by 6. Yes. So omega t naught is what? Pi by 6. Omega is 1 upon under root LC multiply. So pi by 6 into under root LC. So that is what? Second option. Understood? I hope so. This is clear. Next. So this, I don't think so there is any problem. You will not understand. Easy one, doable, but little bit difficult, you can say. Initially, if someone don't click, okay, see, like in initial 15 seconds, if you don't able to click the what to do next, leave it. Next time you can do. Okay, I'll reason. So if someone don't click it, just leave it. If you find out if 30% of your brain is also saying that there is a possibility we will make a mistake in this question, leave it for time being. Okay, first you have to complete the paper, and then after start from the starting. Okay. Next, find omega. This is very easy question. Okay, find omega such that block does not slip on the surface of cylinder. So he can say the minimum omega we have to find out. Okay, because minimum obviously because static friction is acting. Okay, so here what will happen is that when he will rotate, okay, normal will come, and that normal will be equal to mr omega square. So if he is rotating in a r radius, mr omega square. Got it? So friction that will come above, maximum amount of static friction, that is mu into normal, and downward is on mg. Okay, so if any body is rotating like this, okay, is maximum amount of static friction that is available, okay, that is this much. Okay, so you can say mu into normal means you can say mu into mr omega square is equivalent to mg. Okay, so here mu only is asking. Find omega. Okay, omega is asking, so cancel out. Okay, mu r divide, so omega is equals to under root of g by mu r. Okay, whatever is asking, mu or r, whatever. Okay, this is the solution. Got it? But here the maximum, the edge condition is there, that the static friction have reached the maximum value. Okay, according to that. That's it. Next. For a diatomic gas undergoing an isobaric process, work done is 100 joule. Then calculate heat supplied during the process. Okay, very easy. Okay. Diatomic gas, okay, undergo isobaric process. So isobaric process means what? You can say that isobaric. So P delta V, pressure constant, right? So work done is what? Nothing but P delta V, or you can say NR delta T, right? And that is given to you 100 joules. Okay. Now what is the heat supplied? So Q is what? Nothing but delta U plus W, right? Delta U is what? F by 2 NR delta T, and this is NR delta T. So F by 2 plus 1 into NR delta T. This many times this I have done. Okay. Diatomic means how many degree of freedom? 5. Okay. 3 translational, 2 rotational. Got it? So this is 5 by 2 plus 1 into 100. This is 100 given, right? So this came 7 by 2. So 7 by 2 into 100. Okay. So this came 350, I think. Okay. 3.5, 350. So first option. Got it? Very, very easy question. Okay. Next. For the given network, the net resistance across AB is X. Okay, so X is given, and the net when you calculate, then also it is coming X only. So just one equation and answer came. So what you can say here, these two are in series. So you can say 2R plus X, and then with this parallel, answer should come X only. So you can say series and then parallel. R1, R2 by R1 plus R2. So you can say 2R plus X into R divided by 2R plus X plus R. This is R1, R2 divided by R1 plus R2 should be equal to X. Okay. From here quadratic will come, so that you have to solve. Okay. Not that much difficult. So let me bring the quadratic. Okay. Then ahead quadratic you will only solve. So 2R square plus R into X is equal to here how much? 3RX. 3RX plus X square. Okay. So here X square, this Rx this side. So X square plus 2Rx minus 2R square equal to 0. Okay. This is the quadratic which you can solve. Okay. X will come in terms of R, that is only given. Okay. One of the options will match. Depends. That's it. Next. Vrms of O2 gas at 47 degrees centigrade is equivalent to Vrms of H2 at what temperature in Celsius? Okay. So Celsius only we have to answer. So Vrms formula first of all. Okay. Under root 3 RT by M molecular mass. So if I write down for O2 once and then for the H2. Okay. Equal for both of them. So let's equate that directly. Under root will not come. R T by M, T by M. That's it. Okay, 3R. So you can say this is for molecular mass of O2 at temperature of O2, whatever he is, equivalent to 3R temperature of H2 at what H2 is and M of H2. So temperature O2 is at 47 degrees centigrade. But here, remember, here we put in Kelvin. So you will put in Kelvin and answer will also come in Kelvin. Then you have to convert into degree centigrade. Okay. So if you put in Kelvin, what will come? 273 plus 47. How much came? 310, 0. 11, 12, 2, 1 carry, 3. What? 30, na? Okay, 273 plus 47, 273, 280, 320. Okay, so 320 divided by molecular mass of O2. O2 means what? 16 is 32. Okay, this will cancelling out. Temperature of H2 that you want to find out divided by molecular mass of H2 is 2, right? So this will come how much? 20. T of H2 came how much? 20. This is in Kelvin, right? So degree centigrade means minus 273, right? So minus 273, then 20 minus 273. So that is minus 253. Okay, so first option. Clear? Next. Energy of an electron in Bohr's model is minus 0.04 E0 electron volt, where E0 is the ground state energy. Okay. If L is the angular momentum of electron and H is Planck's constant, then 2 pi L by H. So if you understand, what I see here is that Bohr's model he is using, so L is equals to MBR equals to NH upon 2 pi. NH upon 2 pi. So 2 pi here H divided. So 2 pi H by 2 pi L. L by H equal to N. So actually he is asking N only. Okay, he want to ask that if this is the energy, then what is the like N, principal quantum number you can say, of that electron, where in which level, like Lyman, Balmer, what is the N value here. Okay, that is only the direct point. So you can say that 0.04 E0. Okay, so E0 how much? Ground state 0.04. So this is 13.6. Okay, into Z square by N square, N equal to 1, right? So here this is the thing, is equal to how much? Of 13.6 into Z square by N square. Agree? Right? For this is E0, okay, and this is the value for any N, right, which is given. Okay, fine. So now 13.6 Z square cancel out, N square equals to 4 by 100, that is 25, so N equal to 5. Okay, that's it. So N equal to 5, 5 is your answer. That N only is asking. So I hope so this is clear. Next, I think this was the last. Yes, this was the last. So I hope so this all answers are clear. Some of the questions may feel, for an average student, it may feel difficult. But most of the, if you focus just the notes also, still it is doable. Okay, the paper is doable. So I hope so this is clear. Thank you.